Let's dig into the first of the cache coherence protocols, directory protocols. Now, directory protocols are central control. Remember, we've got this central controller that hangs off of the memory bus that allows us to, well, it acts as a big brother which watches all the transactions that are going on, so it can keep track of which blocks have been held in which caches, and what their state is. So, for example, it may know that a certain block of data is held in 3 or 4 caches. It keeps that in its internal tables, and then it may also recognize that one of the CPUs has modified that block, changes the state in that table, saying processor A now owns that data solely because it's been modified, and it makes sure that everybody else's data is invalidated and updates its own tables. The problem with doing this is that anytime any processor wants to be able to do and to do anything with its data, it has to get permission from the controller. So there's a process to this. First of all, anytime the processor needs to modify a line of its cache, it needs to make a request. And that request is made to the controller. Because of this, well, as a result of this request, the controller then looks through its tables to see which processors have this data. As soon as it's got a list of all those processors, or excuse me, all those other caches that have that data, it tells them to invalidate that data. Once the data has successfully been invalidated, and the controller gets a response back from all of those other caches, yes, we've invalidated our data, it goes ahead and says, okay, cool, you can write to your data, and now that processor is the only one that owns that data. The central controller doesn't need to know what value is in there, it just needs to know who has a modified copy. So until another processor requests to read or modify that data that is solely granted to the first processor, until that happens, the first processor has exclusive rights to that data. Once a request from another processor, either to read or to modify that data comes, then the controller will tell the processor with exclusive rights it needs to update. It needs to write back that value to main memory. Once the value is written back, now the central controller updates its own tables to say, no longer does that first processor have exclusive rights, it now has shared rights. And it allows other processors to grab that data. Now, in general, when you're talking about large-scale systems like mainframes and so forth, this is a fairly decent way of maintaining cache coherence. Understand that knowing how cache coherence is performed on your particular system, that may change how you program. It may change how you modify your data. Problem is that that central controller creates a bottleneck. And in fact, if you go back to the earlier slide where I showed you the central controller hanging off of the time shared bus, this is the perfect application for it. But if you remember from that discussion, the central controller also gives us a central point of failure. So if we have a failure in that controller, the system can't work anymore. All right? And in addition, the communication that's being passed back and forth between the central controller and all the cores or all the processing units, man, that's going to give you a pretty significant overhead in bus traffic. These communications include requests to update data, the invalidate commands coming from the central controller to the other processors, and any sort of update request where the central controller tells the processor with exclusive rights, hey, you've got to update your data.